Good morning. Today we are going to see the term work part, that is design of column and design of base. Now in this we have these values. If we will go to your sheet, then we have this dead load on panel points and live load on panel points. So we are not considering due to wind load, because a reaction due to wind load is in upward direction and we have to design the column, and therefore we have to consider combination of dead load and live load only, not wind load. Now reaction due to dead load, so we have total load. So total load by 2. So you can see we have how many? 2.02, 1, 2, 3, 4, 5 and 4, this 9, 1.01 both sides. So we have 10. So we have 2.02 into 10 by 2, and this value comes 10.10 kilonewton. So this is only due to dead load. Then we can have due to live load. So we have value live load. So just replace 2.02 by 2.35 and you will get this value, and that is equal to 11.75 kilonewton. So due to truss, we have these two loads, 10.10 and 11.75. Then we have due to gantry girder, so you have this maximum shear force and bending moment step. In that one, you have calculated maximum shear force, which is R1 equal to 426.39. And you have to consider that as reaction due to crane, which will be your third load, which is in vertically downward direction. Then add all these three loads. Total reaction on column is due to truss, dead plus live, and reaction due to crane. So if I will add all these three, then I will get this will be 448.24 kilonewton, which is total reaction on column. So we have now total reaction on column, which will be total load, which we are saying as PU. Then we will select ISHB 300 because load is not more. So we can have 300, that is sufficient. So now we have this diagram. So we have this as column and this is bracket. So on this bracket, which is connected to the column, and we have eccentric part of this bracket on which we have this section which is of gantry girder. So already you have selected this section and you have designed your gantry, so you know this value. Now you can have this gap. So gap between column and this section of gantry. So this gap we have considered as 10 millimeter. So now what will be my distance from column to the center of gantry girder? So now if I have this, now you can see section. So we have select ISLC. So from center of this, what value I will get? So I will get this value, that is of channel. So this value is 150. So you have this as 150 and then we have value that is 10. So what will be total value in that case? So we have this will be 160. Now we have column ISHB and this is our flange. So yesterday already I explained it. If we have these two dotted line at the center, means we are on flange side, and therefore we have total width of flange 250. So till center we are going to get eccentricity. So what is the value of eccentricity? So we have this will be 160 plus 125, and we have this total value 285, which is 0.285 meter. Now I know PU, I know E, so I will find MU and we will get this value of MU as 127.75 kilonewton meter. So this is my value of MU. So now we know PU, we know MU. Now we can design the column very easily. So now column design, PU 448.24 and MU 127.75. So we have taken these values from here. And then we will start design of column. So now already in the class I have explained AR we have PU plus MU upon DB. So DB, that is depth of the column selected. Now we have selected 300. So we will put the values and we will get. So this is assumed stress 120. You can assume any value, but 120 is sufficient. I will get 7285.44 mm square, and selected section have area 7485 mm square. So it's okay. We need not require to revise this section. So now these are the properties of the section that we have selected for column. So now this is classification of section that I will not explain, that you know already. And this value is less than 15.7. Now it is between I think 10.5 to the 15.7. So it is semi-compact. And then we have web, and web is less than 41, 84. So we have that is web is plastic. So actually these values need not require over here. So we have web plastic. So we have to consider lower part. So our flange is semi-compact. So section is semi-compact. And in this case, beta B becomes ZE upon ZP. Go to 8.2.1.2. Now we will go with design compressive strength. Now we have same step ND AG Fy upon gamma MO. AG 7485, we have substituted value. We got value of ND 1701.14 kilonewton. Similarly, we have now here actually we have beta B, that is ZE upon ZP. And therefore, what happens? This ZP gets cancelled. ZE upon ZP into ZP. And then this ZP gets cancelled. So cancelling ZP, my formula becomes ZEFY upon gamma MO. So keep in mind, for semi-compact, we have ZEFY upon gamma MO. And already we have taken, if we will go to the section, so already I mentioned this is ZEZ. And that ZEZ value is 836.3 and ZPZ is 921. So as my section is semi-compact, so I have taken 836.3 and I got 190.07 kilonewton meter. Then I will check it. So we have checked P upon PD, or you can write it as N upon ND. One and the same. So but as in your IS code, it is given N upon ND. So prefer N upon ND plus MZ upon MDZ, and that is less than equal to 1. Substitute the values and we will get this value 0.9, which is less than 1. So assume condition is satisfied, the column section is adequate for loads. Now we have to go for design of base. Now do not go for eccentric base, because whatever eccentric base you will get from this, that will not be in our syllabus. So we will simply design base plate for load, concentrated load only, that is axial load only. And we have PU 448.24. Sorry, this is kilonewton. So M20 grade of concrete. Now these steps you know. So we have bearing pressure, then we have area required, then assuming A, so we have already this is our critical section. A we know, and from this if we calculate A, it comes minus. So if A is minus, but we are not considering minus value, so we will provide A minimum as 50 mm, and therefore our size of base plate becomes 400 by 350. And then we will go actual bearing pressure, it will be 3.2. Now we will substitute the values in the formula and we will get value of TS 7.85, but it is less than 11.6 actually. So if we will go up, then we have this value. If I will go just above, so I think that value we have 11.6. We have that is 11.6. So we have to go for 11.6. And then that value is less than 11.6. So we have to provide value greater than 11.6. So it is not 10.6. So this value is 11.6. So less greater than 11.6. So we will provide value that is equal to 12 mm, and therefore our size of base plate is 400 by 350 by 12. So now we have again eccentric connection that I will send it afterwards. So now we will stop here only. So thank you.